Hello everyone, this is Rod Sidwell. We're going to talk about activity 9-2, hydrostatic pressure. So I'll just read it here. The pressure due to the height of a column of liquid depends on the height and density of the liquid. The storage tank contains water. Now, the important thing to think about here is it doesn't matter if it's a tiny little column or a very wide column. It doesn't really matter how much water is there. The pressure depends only on the height. What that means is the pressure here is going to be the same as the pressure over here, even though this tank as drawn contains much more water than this one. And I've got my, let's take those off there, got my Purdy's instrument handbook here, and there's a table on page 12, and what you can do is you can use this column to convert. So if I have, for example, if I had 1 atmosphere of pressure, which is the second one, and I wanted to convert that to PSI, I'd come down here and I'd take the number 1, multiply it by this. So 1 atmosphere is 14.69 PSI. If I had 10 atmospheres of pressure, I'd take the number 10, multiply it by 14.69, so I'd have 146.9 PSI. And what you can see here is if I had 1 foot of water column, that's right there, that's 0.4327 PSI. And let's see, did we see a different number somewhere? Yeah, I have 3.2. I'll have to look that up and see. You can check a couple of places if you're not sure. Where 1 foot of water column, that's what I was after, is equal to 0.43332. So I'm not sure how to account for that or which one is exactly the right one, and I will find out about that at some point in the future. For now, just go ahead and use this value in your homework. Okay, question 1. What is the pressure in PSIG in the underground pipe for tank 1 if H equals 168 feet? Well, the pressure is just equal to 168 feet of water column, but they want to know in PSIG. So all I have to do is do like we've been doing for a long time. I take 168 feet H2O, I multiply that by a form of 1, and my form of 1 is going to be 0.4332 PSI per 1 foot H2O. And the feet of H2O are going to cancel, and I'm going to get this number times this number, and it's going to work out to be, what do I have here, 72.778, something like that, PSI, pounds per inch squared. Okay, so they're asking the same exact question for number 2. What is the pressure in PSI in the underground pipe at tank 2, the same height? And we already said that it doesn't matter what shape it is, it only matters how high it is. Okay, question 3. What height of column of mercury is equivalent to 168 feet of water? We know 1 foot of water. How many inches of mercury is that? And there it is right here, 0.8819. 1 foot H2O equals 0.8819 inches mercury. So we can rewrite that as a form of 1. We have 168 feet H2O, and what I can do is I can multiply this by 0.8819 inches Hg divided by 1 foot H2O, because why can I do that? Well, the reason I can do that is if I take this and I divide both sides, hope you can't see it, if I take this and I divide both sides by 1 foot H2O, 1 foot H2O, this divided by this is equal to 1, and I can multiply or divide by 1 anytime I want. So this is this right here equals 1. I can multiply or divide by that anytime I want. So I just put it in there. The units of feet water column are going to cancel, and I get 148. A quick word on decimal places is, maybe 3 decimal places is enough. I got 4 sometimes here that you really don't need that many. 3 or 4 is good. Alright, that's it for 9-2.